Hello everyone. We are going to present this presentation. It's called Building Immutable Data Pipelines with Mesos and EMR. I'm Alan Bover. I'm System Administrator in Schibsted. Also, you can be the DevOps engineer, whatever you want to call it. And
I'm Fabian Sayes. I'm also a DevOps engineer at System Administration in Schibsted. And I was kindly forced to do this talk.
So, what is Schibsted? Or Schibsted or whatever, right? So, does anyone know the company? Schibsted. Schibsted is a Norwegian company that has media marketplaces websites all around the world. It has sites in 30 countries and is currently having a strong digital transformation. Some websites that you might know from Spain is Segunda Mano, that now it's called Vivo, or Mil Anuncios, Fotocasa, etc. So a little bit of context. Not all the sites, but quite a lot of the sites of the company are using the same JavaScript for tracking that collects data from users to us. So with this data, we are currently just getting user clicks. And we are collecting 50 million events a day. In peak hours, we are having 18,000 events per second. Every event is around 2.53K, which it provides 3.6 terabytes of data that we store in S3. We use S3 as a data source of truth, so every data that we collect, we store it in S3, and also all the modifications and transformations that we do, we store it back to S3. So currently, and this is increasing a lot now, but currently we are running around 1,000 Spark jobs a day. So for running this, we are actually using a 4.5 terabyte cluster. This is the minimum, so it depends of like if we have to redo some old data or like there's spikes or whatever, we need to increase. We are moving between 4.5 to 7 terabytes. For the clusters, we are using EMR. I don't know if everyone knows what is EMR. Basically, it's a service on Amazon that allows you to create a Hadoop cluster and in an easy way also to scale it and scale it down. And basically, it provides also a part of Hadoop. It provides other applications like a Spark on top of Hadoop or Hive, etc. So, what is a pipeline? So this is what we understand as a pipeline. A user wants to get some results from some data. So basically, it schedules a job. The scheduler will execute the job, and this job it has several steps. In each step, it might get data from different sources. It will do transformations, aggregation, etc., and then it will store the results somewhere. To administrate everything, we work with a workflow manager, which it provides the scheduler, etc. And the different stages that a job executes to produce this result is what we understand as a pipeline. So, as a workflow manager, we have decided to use Luigi. Luigi is an open source Python framework for batch processing. It doesn't include the stream layer. It's made by Spotify and it was open source on 2012. The different tasks that are executed are based are dependent by each other based on a DAG graph, and it's super multiple tasks. So right now we are only using Spark tasks, but it can execute batch processing, batch task, or Elasticsearch, Cassandra, etc. Luigi has two different components. One of the components is the Luigi server, which basically provides the UI to monitorize the state of the jobs, and also it provides job logging. So it doesn't allow two jobs at the same time run at the same time. And also it has another component, which is the Luigi worker, which basically It's the one that executes the whole graph. So every one of the jobs, it will be executed in the same worker for that specific job, all the tasks. So this is an example of one of the DAGs of the user profiling team. So as you can see, there is a lot of tasks, and they are dependent of each other. And you have like the main task. To be able to process the main task, you will try to resolve all the dependencies first, and then execute the last task. So when we wanted to build this we wanted to start productionize this. We find that we have some problems with this. It's basically Luigi doesn't provide a built-in scheduler, so we needed to provide one. Luigi server cannot scale out, as I was explaining. Luigi server has job locking. For job locking, it uses locking in the file system. So, and it uses the local file system to do this. So you can have multiple instances for that. As the whole job is executed in the same worker, it's hard to fairly distribute the load between different workers. So, exactly that's the thing. So like, all the tasks will be executed maybe in parallel. It has threads, but it will be executed in the same node. And also, Luigi uses Yarn client mode to execute the Spark tasks. So when you execute a Spark task against a Hadoop cluster with Yarn, you can use Yarn client or Yarn cluster. When you execute in Yarn cluster, what you do is that the Spark driver, you send it to the cluster, so you can detach of the task, and then the task will run in the cluster, and when it ends, you will put the results somewhere. But Luigi uses the Yarn client mode because in this scenario, you get attached. The driver runs in your local machine. You get attached to the job, and your job doesn't end until the job ends in the cluster. So it's the way that Luigi Luigi uses to know that he has finished this task and he has to move to the next task. So this is kind of the solution that we were having half a year ago. Every one of the users has its own big EMR cluster. We have a tool that allows to easily create and destroy and basically administrate pre-configured clusters of EMR that we configure with Bootstrap scripts. Also, with this tool, it allows you to easily launch jobs without having to copy the jar file to the cluster and then log into a cluster and execute it. But it has a big problem. It's a big expense of money, because it takes a while to launch a EMR cluster. So maybe you run one job and then you are 1 hour without executing any job, so the cluster is idle. So you're just basically burning money. And also, some people work with the Spark shell, which allows you to execute a task kind of like a Python shell or something. But with this mode, you basically reserve the resources, but you are not using them. Meanwhile, your shell is actually not executing anything. So we did some improvements. We changed on this model, which basically every one of the users have its own instance, but it's a single instance EMR cluster. And then we have a shared cluster, which is the one that I have like the resources to execute the tasks. We needed to keep users having its own instance instead of like putting every user in the same cluster, because every user has his own credentials, and for our auditing we need this to keep being like this. So all the users cannot use the same cluster, because then you will have a lot of credentials and they could see the credentials of each other. With this setup, it allows us to start working with a big shared cluster, which allows us to put some configurations to improve the performance and the cluster usage, kind of like dynamic allocation, queues, preemption, monitoring, etc. Okay, Fabian.
So after all this, we end with this solution. It's kind of big and complex. So the thing that we are going to do now is go through them one by one. So at the beginning, all begins with a user, which is usually a data scientist. And the user only needs to give us two things. The first thing is a Luigi DSL, which is a simple Python script that describes the input that the job needs, the output where it will be located, and other things like configuration, variables, and so on. And also the jar file, which is the Spark job the data scientist, in this case of the user, wants to run. This is, we are using a pipeline command tool, which is called Nox. Nox will get this jar and DCL, will make a package, a next file, and it will load it to our artifact storage solution, which is Artifactory. And this is the end of the user intervention. I mean, this is the last piece of the data scientist will need to interact with the system. From now on, is the system only. So Crane is a small daemon that we wrote because we lack one thing from Artifactory, which is Artifactory doesn't notify us when a change is made. So when you load an artifact or update an existing artifact, you will never get a notification, and we needed the notification to create the Docker container. So what Crane does? First, it will poll Artifactory every second to detect changes. When they detect a change, it will download a new artifact. And it will try to build a Docker container, and if succeeds, it will try to push it to the registry. Imagining that everything is working, the second thing that we will do is generate a job specification for Chronos. Chronos, I will explain later, but it's a scheduling system. And it will use the Chronos API to schedule the job in Chronos. So Chronos is a mesos framework made by Airbnb. It's a distributed scheduling system, and we use this because, if you remember, Luigi doesn't have a built-in scheduler, so we needed a scheduler. And because we want to use mesos to run the workers, this is a natural fit for us. So what Chronos will do when the time comes? Chronos will pull the image from the registry. When the Docker is downloaded, it will try to run the command describe in the job specification. And if something fails, because, I don't know, Chronos cannot contact the registry or the command cannot be run, it will mark the job as failed, and we can query this in the Chronos API. So this is how a JSON specification in Chronos looks like. You will notice that the schedule doesn't follow the usual pattern of a cron tab file. It's a standard, actually. So XT601. But you can see that probably this run will run every 5 minutes when this date comes. Also, it describes a Docker image. It's called job, simple, really simple. And describes also a command, which is basically Luigi. We want to run Luigi with a job task, and that's it. Also, it's nice to have some other details like the owner, so we can email the owner, okay, your job failed, or something like that, or your job was run. And other things like variables, for example, the session name or the ERN, we will explain that later, or the Spark cluster where we want to launch the Spark job. Okay. So Luigi. We are now, the Chronos has launched the Docker image, Luigi is running. So the first thing that the Luigi worker will do is contact the server to check if that task is already running in other worker. If it's not the case, then Luigi will contact S3 in our case, because we use S3 to store all our data. We don't have other data storage, we only use S3. So Luigi will contact S3, will go to the bucket, and it will check if the data is already there. And if it's not there, it will try to generate it or fail. It depends on the job, of course. Eventually, Luigi will launch a Spark job using Spark submit in jar client mode, like Alan explained before. And we didn't tell anything about credentials, about Amazon credentials. Why? We will explain that later, okay? But there are problems with credentials. So Luigi, this is a picture of Spark running in jar client mode. or in yard mode. In this picture, the driver program will be the Luigi worker, and everything else is part of the EMR cluster. So Luigi worker will spawn a new driver. Driver will contact to the cluster manager. It will allocate resources. It will run the tasks. And when the tasks are done, finished, it will send the signal back to the driver. So that way is very cool, because if you are running a job in Spark and you cancel the job because you want to cancel, or the job is canceled because it doesn't have any resources, Luigi will also mark the task as failed. So the tasks are idempotent, which is very cool. Okay, as I say, there are some things with access. So Luigi needs to access S3 to check the files to see if the dataset is done or not done. Spark or EMR needs access also to S3 for read files and web files. And DynamoDB access for use EMRFS for consistency. So of course we can create access and secret keys, a key pair, and inject this key pair in the environment and deal with these kind of things, deal with secrets, deal when the key is revoked, on these kind of things. But we don't want to do that, because this is intended to run production jobs. So we knew and we know that the solution for these workloads or these cases is to use EM roles. But EMR or Luigi didn't have support to use roles. So okay, let's fix that. We are going to fix that. So for EMR, the first thing we are doing, we are paying a lot of money for Amazon. So we ask Amazon support, hey guys, we are facing this. Is there any solution yet? And the guys answer us, yes, there are. You can write a small Java library, and a small credential provider library, and configure EMR to use this library. And this library can generate, can call the API for some roles, and it will give you the credentials. Cool. So actually, this is the property we set in our EMR clusters to signal the EMR. When you need credentials, don't use your standard or default credential provider. Use this one, please. Okay, but you probably are thinking the code is totally long, it's complex. No, it's not. It's a simple class. It's this, no more. The only thing that the provider does is gets the variable from the configuration, the environment, or the files, and calls or creates an assume role credential provider, which is created by Amazon already, and that's it, no more. So we didn't release this library yet because, frankly, it's kind of small, and also we are busy doing other things. But if any one of you needs the library, we can send it to you by email or GitHub or whatever. Okay, this fixed EMR and fixed it really good, but we still lack support for Luigi. So Luigi can read and write from a lot of sources. Okay, we are using Luigi S3 module because it's the thing that we want to do, and Luigi S3 module uses Boto, but didn't have support assuming roles. So let's give Luigi support assuming roles, and we did it. We made a pull request to Luigi, which is a really small change also. And now in master, Luigi can support, can assume roles in S3 and can write and read from S3 using roles. Hooray. So quick summary. What's the whole thing does? The user uses a command tool to bundle a package to or artifact storage. Okay. Daemon pulls the artifact storage, fetch the new artifact, create a Docker image, push it to the Docker registry, schedule the job in Chronos. Chronos will query the new image in the Docker registry, will launch the Luigi worker as a Docker container. Luigi will contact the Luigi server, and if everything is okay and no other worker is running the job, it will eventually launch an Spark job and generates the data. It's simple, right? I think there's time for a demo. Adam?
Hey. Okay, let's the demo gods help us. Actually not, because it's recorded in video. So this is Marathon. Marathon allows us to execute tasks on top of mesos, applications on top of mesos. As we can see, we have Chronos and Crane running. If we go to the mesos UI, we can see that we have the same applications, Chronos and Crane. Now we see Chronos. Chronos is actually executing nothing. If we go to the Luigi UI, we see that there is nothing there. And also if we go to the Hadoop cluster, we see that there is no running applications at all. So this is what the user needs to do. Basically, he has the job, the DSL, and the jar. So he does Nox job deploy, the name of the job, and also he gets anonymized the DSL, and the jar. So what it's going to do now, it's going to get information that it requires. It will build a package with the DSL and the jar. It's a Python egg, and it will upload it to Artifactory. And the job, it's deployed. This is the only thing that the user needs to do. So now if we go to mesos, we can go to the Crane and see the logs of Crane. Basically what Crane is going to do now, it runs in a Crane basis every minute. Every minute it pulls Artifactory and it tries to find if there is a new package or an updated package with a certain pattern. If it finds there is a certain pattern, it will download the package, it will build the Docker, put it in the Docker registry, and then it will create, register this task in Chronos. $60. So the survey, the Crane started, it found the anonymization job. So now it's building the Docker image. Basically is a Docker image that will have everything configured except the job. So it's pushing the job. So it's pushed to the registry and now it's registered to Chronos. So now if we go to Chronos, we can see there is the job running there. We click and we will see that it will change automatically to running state. So it has been scheduled, it has been executed, and now we can see in mesos that it is running. So we can go and see the logs of Luigi. Luigi, I don't know why, it logs in std error. We'll have to look at it, but for the moment it works like that. So this is the Luigi job executing, as we can see here, not that good, but it's executing an sparse submit command. So I actually started to run a job inside the cluster. So now we go to Luigi, and we can see that it's a running task. It appears 23 because it's like executing one task per hour, and 23 hours has been already, they were there, the data were there. So it's actually executing. We can see the dependency here. So if we go to the Hadoop cluster, we can see that it's actually the application running there. Here it appears the workers. This worker is actually the Docker that is it's running in mesos. The IP is actually the IP of the mesos host. I'm going to explain now why. So if we delete the application, we will see that the application disappear from the Hadoop cluster. Okay. The thing that I was commenting, the problem is that if we run in Yarn client mode, we need that the cluster is able to go back to the Docker, so it's able to connect to the Docker. But the problem is that we are running in Docker. Actually we'll get the IP from the mesos cluster and not the IP of the Docker because it's internal. So we need to hack it a little bit and put it in host mode. So it was actually able, because Spark opens a random port. So it was able to contact back.
Okay, so how is really this thing launched in production? Basically, is Mesos Master and Alliance are in an autoscaling group launched by CloudFormation. Mesos applications like Chronos, Luigi, Server, and Crane are launched via Marathon, which is Alan already explained it, but in case that you didn't hear, is a Mesos framework that allows you to run long run jobs services. And EMR is deployed using CloudFormation. Fun fact: we were trying to give EMR support via CloudFormation before Amazon launched their CloudFormation stuff. So we finally deployed EMR using our internal hack CloudFormation support, and a day after, Amazon launched it. Thank you, guys. Thank you. Next steps. Maybe you didn't appreciate it, but debugging this whole thing is kind of difficult sometimes. So we are trying to improve the debugging process. First, we are aggregating the logs in our central log storage. Also, we need to improve monitoring. We need to improve a lot of things. The second thing we want to do is we are running all the jobs in a big shared cluster. This is cool, but we will probably want to run our jobs in several big shared clusters. So in order to find these, the IPs of these big shared clusters, we want to register our clusters in our service discovery, which is Eureka from Netflix. We didn't talk about security, and this is intended because security in Mesos is kind of hard. Also, this service is running entirely in your backend. So no authentication, nothing, no problems because it's a backend service. But if you want to run this in your, or something similar to this, you need to pay attention to this matter, especially in the audit side. That's all. So before questions, we are presenting today, but this is not our only work. We didn't work alone. We want to say thanks to these guys, Jaime, Vicente, Jordi Miguel, the infra team and data team, and also maybe share some of the blame. Why not? Yeah. Thanks for comments. Questions? Can you?
Is there a mix here or no? Okay. You mentioned at the beginning your starting point and how you build this solution as your actual point. Are you working now on what would be the next solution, or are you thinking about ways to the things you want to improve? Maybe to adopt new technologies or enhance a little bit more.
So right now we have quite like a lot of work, I think, to make people implant this. Like the thing is, like, we are making it for a small team, and the idea is that this works for the whole company at some point, which is pretty big. So I think that the main focus of this is right now make this work properly. But well, as it was the slide, it was one slide explaining like the next steps, like by improving this. The good thing about the thing that we built is that the user doesn't see anything of this. He just deploys a job. So if tomorrow we want to change everything, we can.
But if everything in the company is on board, our next step will probably be improve the performance of the shared cluster, improve the policies to auto-scale properly, and these kind of things.
Yeah.
Thank you. I have another question. Can you share, or do you have any indicators of how good or how better it is, this new way of doing things than the way you did it before? You just said that now it was a big expense of money, but besides that,
in terms of money, it's day and night.
but okay, I'm gonna explain a little bit. Like what you see in the second slide I show is actually is one step before that what we are building. Okay, what we are building, we cannot, like as I say, we are starting onboarding teams, so we cannot provide any numbers. But for the solution that we put it, that people were able to share a cluster in this kind of like, I still have my machine, but everything is run in a shared cluster. It's a lot. So the problem is that the clusters before, like every person had, I don't know, 30, 40 nodes, and most of the times the clusters were idle. So they were doing nothing. With this kind of configuration, you can do, for example, dynamic allocation. The dynamic allocation, what it allows you, it's that if you are not using those resources, you just release them automatically and someone else can pick it up. At the point that you have 30, 40, 50 jobs at the same time running, this is really important. I don't have numbers to show you, but I can tell you there is like...
There's no need of numbers. It's just to try to understand internally the feedback you are getting, or the potential of how good it is today compared to what it was in the past.
So we have like I actually have a blog post about this.
Okay.
But it's hard. So you have a one line availability, and the other is cluster usage, right? So you have like your own cluster, like as big as you want it. You have full availability, but then you're spending a lot of money because you are almost not using it. And then everyone sharing the same cluster, then yeah, okay, you have really good usage, but people goes in and they have no resources and they get angry. So the perfect balance of this is hard, and it's like this solution allows us to work on this.
And data scientists are kind of impatient. Sorry.
Okay, thank you.
Come on. No, you can't. I'm joking.
Maybe it's not the fanciest part of the environment, but this crane tool is internal, or do you have a repo somewhere? Because I faced the same problem with Artifactory, like pushing artifacts and grabbing them.
It's an internal tool, but we can share how we proceed to check from Artifactory. But it's really internal tool, and we probably... Okay, it's an internal tool.
Okay.
No, I'm not saying this. No. I probably share. No, what I wanted to say is one of the improvements that we want to work on, but it's like we didn't have time. In Artifact, you can make plugins. So the idea is that all the updates and new packages and everything, instead of based on a pull mode that we are asking Artifactory, which you are overloading it, it's make a plugin for Artifactory. So Artifactory itself publish a queue, the events of the new packages and everything that it happens. And this is probably something that it would be nicer to publish as open source.
When it's done, yes.
Yes. One day.
So we'd rather share nice code than this, which has a model that is not optimal. So rather share the push than the pull code.
Another question? No? Okay, so one last thing. If you think this talk was awesome, or if not, come. You think that it's not awesome, come and teach us. We're hiring, please. So thank you, guys.